All right, so I've been thinking for a while now about presenting Elixir here and why I think it might be interesting for our community. And so when a few days ago I heard that there would be an Erlang talk, I thought this is a great opportunity, and so yeah, here I am. So I can skip a few slides. We're going to save a few minutes because we heard this already. I'm just going to stop here. So as we already heard, Erlang was developed for telecom company needs. And as it turns out, modern web applications are a really good fit for this design of the language. So it's not only a good fit for multi-core systems, but also for web applications. This is a table from the book Elixir in Action by Sasha Juric. And this is one of my favorite parts of the book. And it shows a comparison between a Ruby system, which is server A, and an Erlang system, which is server B. And so for a Ruby system, it is usual to have something like Nginx sitting in front, receiving HTTP request, and then a web application server like Passenger, for example, behind it. In contrast, an Erlang system does not require an external web server sitting in front. You might still want to have Nginx for other reasons, but it is completely feasible to just run the web server as part of your application, as part of the same OS process. So let's say that the Ruby stack runs on Rails, and so we have Erlang on the other side. And it is not uncommon for Ruby systems to bring in other external tools when you want to solve a specific problem. And so in the case where we have long-running requests, let's say that we want to handle WebSockets, we might bring in another server that is written in Go. On Erlang side, we don't have a reason to bring anything else in because any kind of request, long-running or not, is still a good fit for the language model. And so I think you see where this is going, right? So the point is that in an Erlang system, everything can be handled in the same project. And not only that, it will run in a single OS process. So Ina was talking about like thousands and thousands of processes, but this is all the time, this is still a single OS process because it's handled in the Erlang VM. And so we can avoid having to deploy each component separately. And imagine how much easier it is to, when you want to get started on your local machine, started with development on a fresh project, when you don't have to bring like 10 different programs on your laptop before starting. Am I the only one who spent like a day or 2 days setting up a new project recently? Hopefully not. Or am I doing something wrong? Okay. So Elixir. Elixir is a newer language for the Erlang VM. And the premise is that you can use this new language and benefit from everything that the Erlang system has to offer that we already heard earlier from Ino. It has a modern syntax that is, in my opinion, cleaner than Erlang's, but I like Ruby, so yeah, it's a different opinion. In my opinion, it's also more compact and more expressive, and it makes development on the Erlang platform more pleasant. The goal of the language, as stated on its website, is to be able to write to be a dynamic functional language for writing scalable and maintainable apps. It is a functional language. It has features like pattern matching, as you all heard before, and immutable data structures, and so on. It takes advantage of the concurrency model that Erlang brings, and it takes it further by providing new abstractions on top of it. First-class macro support makes it very extensible and allows us to write all kinds of ridiculous DSLs. And it compiles down to Erlang VM bytecode. So it is a compiled language. So why do I think that Elixir is interesting to me as someone who writes Ruby like for his everyday job? So first, a lot of things are very familiar, starting with the syntax. So this is just a very simple hello world example, nothing fancy. So there is a module definition. There are no classes. So there is a module, then there is a function definition. It takes an argument called greeting, then it does some string interpolation, and then it prints the standard output, and then there is the invocation at the bottom. So all pretty basic stuff. And when we run this program, we get the output. So it feels kind of familiar, right? Right? Huh? Well, Elixir was partially inspired by Ruby, which is not unexpected because the creator of Elixir is José Valim. José is a long-time Rails contributor, and there are more than 200 other contributors to the language, but he's the one that gets the last say on everything that goes or doesn't go into the language. It's kind of like Mets does for Ruby. Here's an anecdote about how the Elixir name was born. It's from the IRC channel, so nobody knows. Anyway, I think this is one of the cool things, is just you can just go on the IRC channel. The community is still so small that you can get access to José and all the contributors, and you can just ask them questions, and they're all very helpful. So what else is familiar? Like in Ruby, in Elixir, we say that everything is an expression, so there is no distinction between statements and expressions. And like methods in Ruby, functions in Elixir have implicit returns. So the last expression in a function is the result of the function. There is a comprehensive set of enumerable methods, which is one of my favorite parts of Ruby, and it's almost equivalent here. And then there is the interactive Elixir shell, which is like IRB. So there's a lot of cool stuff that we use from Ruby. It's also present in Elixir. So what can we find in Elixir that Ruby doesn't have? We've already heard about pattern matching. Let's see how it looks like in Elixir. It's probably one of the most advertised features of the language. Elixir took it from Erlang, of course, which I think in turn took it from Prolog. I'm not sure. Yeah, okay. But other languages have it as well, and it's not specific to functional languages. It's just a very useful feature, and here is a very simple example. So the equals operator will try to match the list on the left side to the list to the right side and try to make them equal. And this way, the result of this is that the variable a will be assigned to the number 2. Does it make sense? Pretty simple. And in fact, in Elixir, there is no assignment, but there is a match operator instead. So let's look at an example. This is one of the many ways where pattern matching can be helpful to clean up the code. So we've already seen module definition, function definition, and this is an imaginary function, so there is no real implementation. This is a tuple. We don't have them in Ruby, but I think you're familiar with tuples. And this is an atom, which is like a symbol in Ruby. And so let's assume that this function is defined in a way that it will either return what we have on line 7 or what we have on line 9. So this is not like implementation. We have just these two possible outcomes, okay? And this is how we can use pattern matching to specify that we are expecting the response to be successful. We say that we expect the result of the API call to be a struct that has 2 elements, the first of which is an OK atom. And so the match operator will make sure that this is true. Otherwise, the matching will fail, and subsequently, the program will fail as well. Realistically, we might want to handle the error as well, but like there are other constructs for that. This is just the basic gist. All right, and of course, the response variable is assigned as well. So data structures in Elixir are immutable. Mutability, kind of like what Ino said about shared process state, shared memory. For similar reasons, mutable data structures are hard to reason about for programmers, and this is where a lot of bugs come in. So functional languages try to avoid this idea altogether, and they force you to think about data pipelines and how to write programs in a way so that they are easier to reason about and easier to debug. And now my favorite part of the language, which is the pipe operator. I could talk for 20 minutes just about this, but I won't because I don't want you to fall asleep. So let me show you how things look without the pipe operator first. So this is just a function invocation. So unlike in object-oriented languages like Ruby, where you call a method on an object or you send a message to an object, you don't have this in functional languages because they tend to separate data and behavior. And so instead of calling a function on a value, we pass the value to the function. And this is how chaining functions looks in most languages. You start with the array, you pass it to the sort, and then you reverse it. And basically, you read from right to left, from inside out. Yeah. And this is how the pipe operator works. I don't think it even needs an explanation, right? It's like the Unix pipe operator. Just the data goes from left to right, and it's very natural to read, at least for us, because we are used to reading from left to right. And it can also span multiple lines. This is a bit of a contrived example, like presentation examples tend to be, but hopefully it conveys the usefulness. So on lines 2 and 4, we have something similar to Ruby's symbol to proc. There is a slash at the end, which is the arity of the function. This is how functions in Erlang and Elixir are referenced. The arity is important. And on line 3, we have an anonymous function, the fn, which is the map. We multiply every element by 2. Yeah, pretty cool, right? So in short, I'm a big fan. I think Elixir stole it from F#, and I just wish more languages had this. So there are a few other things that I don't have time to cover because I promised to make it short, and I'm already at 13 minutes. So protocols are Elixir's approach to polymorphism. Streams are like lazy enumerators in Ruby, but a bit better in my opinion. And then there's comprehensions and guards and a ton of other features that are common to functional languages. In summary, I find the language very fun and enjoyable to use. And in many ways, to me, it feels like Ruby felt, I don't know how many years ago when I first looked at it. So I'm really excited to write programs in Elixir. And last but not least, I want to mention the Phoenix framework. It is a web framework, and it has a lot of the stuff we like about Rails. It's not 1.0 yet, but it's already very enjoyable to use, and people are already running it production, because why not, I guess. And so I'm going to highlight one thing. This is the log of a request. And if you look at the last line, you see that the response time is reported in microseconds, which I think is pretty cool. And granted, this is a very simple response, but the app that I ran was in development mode, so yeah, it's quite impressive. Yeah, I think you should check it out, and that's all I have. Thanks. Any questions? I don't know. I've been working on a project for 2-3 weeks now, for like 1 hour a day maybe. I don't know how to quantify the size. It's a bit more than trivial, I'd say. So it's still pretty simple, but I'm trying to get the hang of the language. I'm just getting started.
What's most painful about learning?
About learning?
Yeah, for now.
I don't know, actually. Can't think of anything. I'll remember something and I'll tell you later. Yeah. So I waited just long enough so that the documentation got good enough, because I heard that before 1.0 Elixir is now past 1.0, but before you could get like stack traces that had a lot of Erlang in it, so it was hard if you didn't know Erlang, but this is not a problem anymore. Really, I'm sure I'll think of something and I'll tell you later.
Do you have to know all of Erlang?
No. It helps to know stuff. Well, it depends what you call Erlang, because Erlang is actually called Erlang/OTP, and OTP is the Open Telecom Platform, right? Which is this set of really useful stuff that you use to build servers that we heard about before. And this is the stuff that you need to know, because it's basically, from Elixir you can just call Erlang code, and basically you're using this exact library when you're doing server processes. And so yeah, you need to know this. But you don't need to know Erlang syntax, maybe. Yeah, that's not needed.
Okay, thank you.
Thank you.